PSC2-2 is about solving problems using the area of similar figures, so polygons and circles, and the volume of similar solids, so any 3D shape. So in this example, we want the ratio of the side to the side, which we can write as 3 to 6 or 5 to 10. Both of those simplify to 1 to 2. When we're doing our ratios, we always want to write them in simplest terms, and you'll see why in a minute. When I get to my areas, this area is 15. This area is 60. If I write those as a ratio, and then I simplify, that's the same as 1 to 4. The shortcut is, which you're about to learn, I can take my sides and I can square them and I'll get the ratio of area to area. Okay, now this isn't saying that either of my areas is 1 or 4. It's just saying if I take my areas, 15 out of 60, and I simplify them, I'll get 1 to 4. So if corresponding sides of two similar polygons or the radii of two circles compare in the ratio m to n, then their areas compare in the ratio m squared to n squared. Okay, so if you know the sides and you set up a ratio m to n, you can find the areas just by squaring both. Alright, so we want to think about, are these prisms similar? And then when we're looking at them, 6 to 3, 14 to 7, those are the same, but 2 to 2 is not the same. So our answer has to be no. Okay, just like in 2D objects, 3D objects, everything has to be proportional in order for them to be similar. Looking at these, however, okay, I have 8 to 12, and I have 14 to 21. And those are the same, right? Because they both simplify to 2 out of 3. Right, so if corresponding edges, radii, or heights of two similar solids compare in the ratio m to n, okay, you're going to use your noggin here for a second. We said our sides were m to n, our areas were m squared to n squared, which means our volume has to be m cubed to n cubed. To put that all in a pretty little picture, sides, again, m to n, area, m squared, n squared, volume, m cubed, n cubed. The shortcut for this, I think my units would be like just my units. This would be units squared. This would be units cubed. Okay, if that helps you remember, awesome. If not, that's okay too. I would write this on the top of your homework. I would even write it on the top of your test when you're testing on Friday. Alright, so we want to know if the ratio of the areas of two similar pentagons is 64 to 25, so that's my area. What's the ratio of their perimeters? Now I think perimeters, that's going to be just in units. Okay, so it's kind of operating the same way that a side would. So to find that, I'm taking the square root of each of those because I'm going backwards here. Right? I have m squared, n squared, and I want m to n. Square root of 64 is 8. Square root of 25 is 5. I don't even need volume. Okay. This time we have parallelograms, and it should say parallelogram prisms of some sort. And the ratio is 3 to 4 on my sides. We want the volumes, okay? We have m to n. We want m cubed to n cubed. Now, if it helps you, you can absolutely stop at m squared, n squared on the way, right? There's no harm in writing 9 to 16, but that doesn't really help me find my answer, other than taking 9 times 3 again is 27, 16 times 4 again is 64. You could have also just done 3 cubed over 4 cubed. There's my ratio. All right, and then we're told that, hey, the ratio of two volumes is 1 to 27. What's the ratio of their areas? I'm going to hop all the way back here by taking the cube root. The cube root of 1 is 1. The cube root of 27 is 3. To find that on a calculator, on a handheld one, you're hitting math. And then you're choosing the cube root, which is usually option 4, or the nth root, which I think is option 5. Okay? If you're on your iPad calculator, you're looking for that symbol, and you're going to type a 3 in there. Anyways, once I have my sides, I just need to square them to find my area. So 1 squared is 1, 3 squared is 9. And again, this is not your actual area, it's the ratio of your areas. Okay, I have no idea what my area actually is, but I know that when I write my areas as a fraction and set them equal, or simplify them rather, they have to equal this. All right, we're going to do an example where we actually solve for an area. So I'm going to start with my side and my area. Volume isn't really relevant right now, so I'm not worrying about that. And I have 6 out of 9, and it's easiest to do these problems if I put this in simplest terms. So 6/9 is 2/3. Now I need to write out my area ratio. So I need to square both of them. So I get 4 to 9. Neither of these is the area itself, okay? But it's the ratio my areas have to be in. I'm using that ratio, not my 2 to 3. I'm using the squared version, so 4 to 9. I don't know my small area, but I do know my big area is 54. To solve, I cross multiply and divide, and then get that my area is 24. If you click on the notes in this folder, there's also a link to a YouTube video of someone else explaining it. You can also, of course, rewatch this video.